Hi, my name is Claudia, this is Fred and Luis, and we're doing the SA Aero Design Competition. The competition consists of 75 teams that are going to create an RC aircraft based on set requirements. We will be competing on the regular class. Some of the requirements for this competition include the total dimension of the aircraft of 175 inches, 65 pounds of maximum weight. We have a determined path where the aircraft has to travel and also take off and landing. For this competition, a change that has been made is that we're now using an electric motor instead of a gas engine.
So for the objectives of our design, we have three main objectives. The first one is to improve and to optimize the design of the aircraft using the CFD. We have to improve the analytical structures of the plane using the final element analysis. And we're going to be trying to approach the lowest manufacturing time with the lowest cost as possible for the aircraft. When it comes to the global learning, the perspectives that we're going to be working with a PhD student of the University of Venezuela who already went to the competition. When it comes to the awareness, we're going to be using materials in our design that are only safe for the environment, and that we're going to ensure the safety of everyone working in the competition. And for the engagement, we're going to be using current technology to improve the design of our aircraft.
Well, when it comes to the components of the aircraft, we have our main components divided into mechanical and electrical. We are mostly focused on the mechanical part, which includes the structure and the propulsion system. On the structure, we'll go for the fuselage, tail, and wing. That's our main objective. And for the electrical part, it only covers the battery and the electric motor, since it's an electric airplane that we're building. Okay. When it comes to the wing design, we have three different options. We have a high wing for high stability, the low wing, which is mostly used in aerobatics, and a mid wing. For the airfoils, since we're looking for high lift and low velocity, we're planning to go with a camber type airfoil. If you can see the different airfoils, like the symmetrical is better for aerobatics. For the wing shape, right now we're going with a taper type wing.
So for the empennage of the airplane, there's different options that we can choose. Basic components of the empennage include the vertical stabilizer and the horizontal stabilizer. The most common tail designs include the conventional tail, the twin tail, and the T-tail. For the conventional tail, it's very stable and it's easy to construct. The T-tail provides a lot of stability, but the fact that it has a horizontal tail, then you need to make the vertical component more stable, so it adds weight. And the twin tail is a very good design for our option because it allows us to keep the requirements of the high low.
Okay, for the fuselage, we had three choices. The monocoque design, the semi-monocoque design, and the Warren truss. However, due to economic reasons and time management, we decided to go for the Warren truss design. So for the conceptual design, this is not the one we're using right now. That we'll show that on the next slide. But the design that we'll have an H-tail, the high position wing, and the winglets. And then for future design, we're going to try to put a ducted fan propeller in top of the wingspan, and to put micro vortex generators for better flow, and the retractable flaps to improve the lift.
Okay. As of right now, this is where we are. This is our structure for the airplane. As you can see, we're planning to construct it in balsa wood. We have two proposed designs, one with the front propeller, like conventional, and then we want to try and go with a ducted fan on top of the wings to see how that works. And since it's an open design, we have some room to play with it. We have the fuselage, the wing, and the H-tail. That's what we're going with right now.
For the process of our project, we're going to have first the conceptual, then the analysis of the structure. We're going to do some wind tunnel testing and bench testing, and then we're going to construct and do flight tests. Here you can see the timeline for our project. And this is our cost analysis. Half of the cost is based on the project registration of and the plane tickets. And this is a breakdown of the cost.
Questions?
Okay, any questions? Yeah, I have a couple. The graphics you had earlier on with the various profiles and all of that, where did you get those diagrams from? Could you bring it back up?
Yeah.
That, where do you get those graphics from?
Yeah, those are all from different resources from the website. In our report, we have referenced all the images that we obtained.
Okay, it might be a good idea to cite them there as well.
Here too.
Okay.
And
So do we do like a separate slide?
down,
at the
no.
end?
No, just a
Oh,
line
just
under
one.
each,
Kind
just a
of.
line under each.
Lost.
Okay.
And the font size is not visible.
Yeah, I cannot.
Okay.
Okay, we might just go with the shape and not the description underneath.
Yeah, maybe you can do that.
Well, not all of the description. Probably all you need is the profile and what it is. So you'd say low camber and so on. You don't need the other
Okay.
information. Not on the profile. In the body of the text, you expand it.
Oh, I see. Okay.
Could you go to the next slide? That one there. You've talked about the empennage in your discussion and in the structural detailing of it, that it's an H-tail, but that's not an H-tail.
The H-tail and the twin tail, they're both the same. They're
No, I'm a pilot. I know
Okay.
exactly what you're talking about.
Uh-huh.
I'm talking about the diagram there.
Right.
Oh, yeah,
That is
this
the
is just
convention
to explain the components of the empennage. It's not.
Okay, well, go to the next one, because there's another one right there. On that one, you spoke about the H-tail.
Yeah, but however, I did say that that was not the design that we were using.
This is what we
So
were
we're gonna change it.
initially
Oh,
starting
so you're gonna
from.
change that
Yeah, for
graphic?
the presentation,
Okay,
we're gonna
okay.
have.
Exactly.
Yeah, if you
Alright.
go to the next slide.
We
Fred,
are.
No, I agree, I saw
that.
that, and that's what I'm saying. You haven't detailed there properly, but on the previous two.
We are working right now.
So this is a work in progress.
please.
Yeah.
Yeah, those are the beginning and.
Okay.
To the structure. We're planning on getting this one now in a SolidWorks model like the previous one, so we can show the whole airplane basically how it will look when it's finished.
Yeah, but
It will mostly.
So you'll have that ready on the 4th?
Yes.
The SolidWorks, yes.
Okay, good. As well as the new graphics.
Yeah.
Yes, yes.
All right, and the timing was good for the
Yeah,
presentation?
very good.
Excellent. All right, I have no further questions.
When you go to the timeline, we've been telling you again and again, don't use the 10% reports, 25% reports. You need to work on it, okay?
And you can use 2 slides for that. I would put the schedule on one slide.
I mean, it's a course schedule and they will tell them not to put the course schedule. Like the 10% report,
Right.
20%.
Just to put it on the second slide, maybe to read it better? Is that?
And
Yes,
you
yes,
need to,
right.
yeah,
Because that would be a heavy weighted element when the IAB is here.
Okay,
So they're gonna be looking at schedule and division of labor. They look at that very heavily. So just so that you're not being criticized and the questions are not being asked, I think if you take that second visual and put it on a separate slide and blow it up and do the same thing with the sequencing, that would do you a lot of good.
Okay.
And font size is too small on the slide.
Yeah.
Yeah, well, when he blows it up, that,
Yes.
Yeah.
if he does what I tell him to
Yes.
do, that will solve that problem.
That was all.
okay, and do you have any sponsors for this?
No.
We're currently working on getting some funding and also contacting airlines so we can get better fares for
for the
plane
tickets, yes.
And one other point, and this is not a question, it's a point. I didn't hear you, nor do I see it there in your process, talk about the global learning component.
Oh, we talked about the global
Yeah, it is
learning
there.
in the beginning. Oh, I did.
You
I
can go
talked
back
about
to the
the
previous slide.
collective awareness and engagement.
That was probably the third slide.
Okay.
Yeah.
Should we have this slide at the end or?
I would probably put it towards the end, wouldn't you?
Not at the end, but towards the end it will.
I'm sorry?
Not at the end, but
No, towards the end.
Towards
Towards
the end.
the end,
By the
yeah.
timeline. and-
Yeah, towards the end, yeah.
towards the end.
Okay.
Please, any more questions? We want to be ready when the time comes.
Any questions?
Yeah, sorry, I wasn't paying attention on the first slide. What's the length of the plane, the dimensions?
It's 175 inches combined between wingspan, length, and height of the airplane when it's sitting on the floor. So we have taken into consideration the landing gear as well. You know, that's why we went with the H-tail, so it's a little lower.
And what are the restrictions for the competition, as in size restrictions?
Well, we have, on materials, we have restrictions, like it is
You cannot
composite
use
materials.
composite
We can only
materials.
use one propeller as well.
Right.
The engine has to be electric.
Mhm. We have a power limiter of 1,000 watts or 200 amps. That, you know, that's part of the restrictions of the competition. We have 20 pages if you want to read about it. You know, as well, the runways that we use, you know, the length for landing and for takeoff, you know, is a very limited factor for when it comes to the design.
Any other questions? Okay, thank you, La.